Okay, I just put this note in the ULearn just now, and this is the topic of derivative. Okay, I'm quite sure that you are already familiar with this topic from your previous study. Okay, now this is derivative. In Malay, it is pembezaan. Or if you read a book when it call about rate of change, which is beza, kan? That's also derivative, pembezaan. Okay. Um, hmm. Okay, this is the outline, differentiation of function, and it is the continuity of the function also. And here, after that, we learn about rule of differentiation, higher order differentiation, implicit differentiation, and application of differentiation. Okay, pembezaan. So, what is pembezaan in terms of function? Okay, first we have to know the fundamental concept. What is pembezaan inside a function? Okay, for example, if we have, remember previously, graph is one of the representation of the function, right? Then what is differentiation? Okay, of a function. It means that contoh hari ni, okay. Contohnya, okay, kita ambil rate of masa. Masa contohnya masa 1 jam, 2 jam, 3 jam, okay, 4 jam macam tu. So, kita nak tahu pembezaan. Okay, contohnya pada masa bermula kosong, kereta ni dia punya kilometer, this is 1 jam, 2 jam is time, right? And this is kilometer. Macam tu. Okay, contohnya masa kosong dia 0 kilometer. But when it is 1 hour, it is 30 kilometer. For example, it is 30 kilometer here. And after the 2 hours, it is it is 60, for example. Okay. And what is differentiation? Differentiation ni, it is the perubahan masa daripada perubahan laju kilometer ni daripada masa 1 jam ke 2 jam. Itu sebab bila kita kira kilometer per hour bahagi kilometer pada masa 2 jam tolak kilometer pada masa 1 jam bahagi dengan 2 jam tolak 1 jam, ini macam kita cari slope tau. Slope yang di sini. Okay. It is actually, it's differentiation. Differentiation, which is differentiation lah. It is dy over dx. Actually, previously we learned it as m, which is the slope. Perubahan dia tu ialah dia punya kecerunan dekat sini. It is perubahan dia. Yang ni lah differentiation of a function. Previously you had learned it in a garis lurus tu, slope tu, it is also differentiation. Okay, then we learn about rule, higher order. Okay, ni dah cakap tadi Okay, that's the thing why the motivation why this topic came out in the function, the continuity of the topic function. Okay, then this is the differentiation of function punya explanation. Okay, it's a fundamental concept of calculus. To carefully understand the differentiation, which is derivative, it is the concept of limit in chapter 2 and the concept of slope tangent in your tutorial 1 previously. Then you must first be understood. Okay, then keeping the above in mind, the differentiation of the function by using the first principle. This is the first principle. Okay, actually the first principle ni, it came out from the equation of slope. Kenapa saya kata ini daripada equation of slope? Contoh kita ada graph. Okay, ini ialah fx kita. And kita nak cari ni. Okay, tadi kan daripada sini ke sini. Yang ni ialah 30 kilometer, yang ni ialah 60 tadi. Okey, maksudnya kat sini yang ni ialah F60 tolak F30. Bahagi dengan, okey yang ni tadi ialah masa 1 jam and ini ialah masa 2 jam. 2 tolak 1. This is the H, which is dia punya jarak di antara ni. Which is ini ialah X2 tolak X1. Okey, ini ialah kita wakilkan yang bawah ni sebagai H. Okey, nampak tak ini dia datang daripada formula M. Kan MY2 tolak Y1 bahagi X2 tolak X1. Nampak tak? Ini ialah itulah. And when it is involve the kita nak tahu menghampiri X, menghampiri ni, it is actually the limit. Limit H menghampiri kosong macam tu. Ini ialah di mana formula ini bermula. Okay, it came out from the concept of slope. Okay, then this is the concept just now that I explained to you, and this is the slope that you find it, and this is the F 30, 60 tadi tu when it is involved the changes about tadi kan daripada 30 ke 60 dia punya changes ialah 60 tolak 30 ialah 30 and this is the changes of X. Itu sebab kadang-kadang ada buku dia kata differentiation ni is the rate of change. Okay, then we can remove. Okay, if there is question you may ask and this is the differentiation of function. Okay, intuitively the derivative give the change. Ingat pembezaan. Perbezaan dia in the dependent variable that occur when the independent variable increase by 1 unit. Okay, is there any question about this first sentence? What is the dependent? What is independent? Do you know it? Or you forgot already? Independent, dependent? Okay. Then saya mute dulu dengar suara saya. Okay, independent variable and dependent. Kalau kita ada X dengan Fx, mana dependent, mana independent? Nak tanya dulu, mana dependent, mana independent? Independent ialah dia tak bergantung kepada apa-apa nilai, which is it. Dia free. Which one is dependent? Which one is independent?
X is independent.
Okay, correct, Ezra. X is independent because of if we have the table, we put the scalar 1, 2, 3, 4, for example, it's not depend on any value, so it is independent. Then Fx is depend on the value of x, which is, what is the value of x1? Then we can plot Fx after we get the value of 1, which is Fx is depend on the value of x, which is the Fx is dependent. Tu beza Okay, apa itu independent, apa itu dependent. And in our equation, we know that yang atas ni ialah dependent tadi Fx tu lah. And it's divide with the independent x yang bawah. Okay, then here, this is one example. The idea behind the notion of differentiation is, for example, you leave Naka by bus at 10 a.m. on Saturday morning and arrive in Tapa at 2:15 p.m. The distance between Melaka and Tapa is about 260 km. So the bus average speed between Tapa is here, which is we know our time when we when we start our bus, then we count the kilometer after we end, then we can calculate the laju. And from there, it will, if you do the analysis, which is we know about prediction. Okay, there are a lot of application involve prediction nowadays. Okay, for example, your car, kalau kita nampak kalau kereta sekarang ni, it can predict, which is it know already how many kilometer for our apa fuel. Maksudnya kita punya minyak tu boleh sampai berapa kilometer lagi. Sebenarnya kalau dia bijak enough, dia kira daripada kita punya kadar laju, kadar kita punya laju kita bawa kereta selalu berapa macam mana. Jadi dia boleh kira lah. Okay, in this berapa amount minyak tu, so kita boleh jalan berapa kilometer. Tapi kalau dia bukan intelligent punya sistem, dia guna macam dummy, maksudnya by default je lah macam tu. Bukan berdasarkan orang tu personal punya macam cara pemanduan. Macam tu lah. Okay. And a lot of apps like macam kita tengok Strava pun dah tahu dah laju dia kira juga kan macam tu. And kalau contoh another tu ialah apa? Kalau kita tengok apa lagi? Saya rasa kalau kita tengok diet punya application pun macam tu juga saya rasa. Bila kita tahu kita nak turun berapa kilo and we know already your weight ni macam mana, so dia calculate berapa kalori selalunya sehari you kena turun. Itu pun ada kena mengena sebab it involve changes. Kita nak berubah dari satu hari ke satu hari. So it will apply differentiation there. And this is the example one. Okay, this is by using first principle. Okay, we want to count differentiation of y is equal to x square by using the first principle. Okay, this is the first principle rule, formula, and we put it dekat sini. Okay, lepas tu kita cari dia punya limit. Okay, bila kita tengok dekat sini, bila dia involve limit h menghampiri kosong, when we direct substitution, ingat balik topik limit last week, which is kosong over kosong, ni dia dapat kosong over kosong. Then here kita kena buat apa? Factorization, right? Itu sebab h kat bawah ni hilang. Sebab kat atas ni ada hilang satu-satu. Kita factorize h to the outside, then we get 2x minus h, then after we do the direct substitution, we get 2x. Okay, are you good? Clear with me? This is the formula of first principle of differentiation. I know you raise your hand, what you want to ask? Tekan. Okay. Move Okay, this is the derivative of a function. Okay, ini kalau dia bagi tahu satu titik XA. Tetapi selalunya saya tak tekankan yang ni sangat sebab if you already know this kind of formula, you can use it in every situation. Okay, kalau kita tak guna yang ni pun tak apa. Tapi kalau kita nak guna, kita dah tahu satu titik yang dia nak cari. Contohnya soalan macam ni. Dia dah bagi tahu dia nak cari differentiation untuk titik A sama juga dengan 2. So kat situ dia guna first principle. Jadi kita boleh straight away using FA. Kat sini gantikan kat it's different with this. Ni kita guna fx, right? Yang ni kita terus letak fa and this is fx and here is nampak tak? Formula dia berubah. Tetapi saya kata kalau kamu tak ingat benda ni but you stick for this formula only, you can manage to solve it also. Okay, this is An example je lah kalau kamu nak tahu. Dia boleh cari menggunakan rumus yang ini. Okay, then tengok soalan ni. Rumus dia yang ni FA. FA bermaksud kita gantikan A dengan 2. Kat situ A dengan 2. So F2 terus dapat kat sini. Ialah ni kita gantikan terus dengan 2 dekat dalam soalan fx ni, and fx it's remain. And yang bawah ni ialah x tolak A. A apa? A ialah 2. Then we finish it, and limit here, look at the limit, it's not h approaching to 0, but it is x approaching to A. But okay, then we can solve it and we have this value. Or you want to use limit h approaching to 0, f x plus h minus f x divided by h. To this kind of question, if it is asked about first principle, you can also boleh lah, boleh try jawab. So can I move to the next slide? Boleh. Ada chat. Oh, I know tertekan tadi.
Boleh, Doktor.
Okay, saya rasa saya tak payah nak beratkan sangat. Saya rasa topik ni is quite simple, right? Okay, then we go for tutorial. We look at the question later. Okay, then this is the rule of differentiation. Beside you use the first principle just now, you can use this. Kenapa kita belajar first principle? Kenapa kita belajar guna rule? Rule ni ialah bila kita ada one equation tau. Equation. Tapi diorang kenapa terciptanya first principle? Because of in this world, selalunya masalah masalah yang kita perlu selesaikan untuk rate of change derivative, bila kita buat eksperimen, we can't see this kind of rumus. Kita tak dapat rumus, kita akan dapat graph. Kita akan dapat, okay, kalau kita buat, kita nak cari haba, perubahan this kind of material terhadap haba. Okay, kalau kita buat uji kaji dalam makmal, or we do it in our bengkel untuk kereta-kereta kan, kita nak tahu the performance of the engine. We can't find it, we don't have this kind of rumus, but the quite yang paling hampir dengan seorang researcher tu ialah nombor. Kita akan dapat graph, kita akan dapat table, and we get the nombor, then we can plot it. Then we know the performance of this kind of engine by using this the nilai-nilai yang kita dapat tu sebenarnya. Kita tak dapat rumus. Okay, bila kita nak create rumus ni, kita kena jumpa mathematician ke, macam tu lah selalunya. Tapi selalunya kita kalau kita buat keputusan untuk sesuatu research center tu, kita nak keputusan yang pantas, kita dah boleh cari menggunakan nombor-nombor yang ada. So sebab itulah mereka menggunakan this kind of formula, formula yang tadi ni, yang ni, sebab kita daripada graph tu saja. But in this calculus, we assume that we get this kind of equation, and from this equation, it's important to you to know how to find the derivative also. And after this, we will learn how to use the angka-angka tu guna derivative, kita guna kat dalam numerical method. Okay, sebenarnya untuk researcher, untuk on R&D department dekat dalam kilang-kilang ke apa ke, the most paling hampir dengan mereka ialah nombor and the numerical part actually. But we can't tinggalkan yang ni juga. Bila kita ada satu equation, sebenarnya lagi mudah untuk dah cari differentiation. Okay, itu sebab untuk course ni kita belajar differentiation using calculus, and later differentiation using numerical method. We involve the numerical part. Okay, in this constant rule, okay, if we have equation like this, constant C, okay, here kat sini, okay, every constant tu ialah nombor and you have to remember pi is also the nombor, exponent tu is also nombor, because if you press your calculator, you get this kind of number. Or you put ln 5, it's also number. All this beside we have nombor biasa, contohnya 5, 1000, 2000. Yes, lepas tu kita ada negatif 50 contoh. Okay, this is also nombor. And all this kind of number, we know that the rule of differentiation untuk ni akan jadi kosong. Dia sentiasa akan kosong. Boleh? And if we have x power of c, for example, x power of 5, it will become c, letak dekat depan, tengok ni which is 5x power of 4, which is yang ni 5 minus 1, dia dapat 4. And our 5 ni ialah our c just now, and it is like this. Okay, rasa okay rasanya, saya rasa untuk kelas ni okay ni. Okay, kalau tak okay nanti besok masa kelas bagi tahu Okay, then bagi tahu sekarang pun tak apa. Okay, lepas tu kita ada constant coefficient rule. What is it? Okay, constant coefficient rule ialah bila kita ada 5x kuasa 2, which is constant tu dia tetap dekat depan, which is 5. Bila kita cari derivative dia tetap 5, tapi kita kena differentiate yang depan belakang ni, which is 2 pindah dekat depan, kita guna power rule punya konsep, which is C kita 2x kuasa 1, then it will become 10x. Okay. Lagi satu saya lupa nak cakap. Untuk derivative, kita punya simbol tu dy over dx, or we have this kind of equation ada prime kat atas tu, f double prime, itu pun derivative higher order, second order. F prime ni it is derivative also, and this is derivative also. Okay, then we go for next slide. Okay, sekarang dekat sini, ini ialah untuk sum rule. Ini maksudnya kita bezakan fx dan we bezakan gx. Contohnya kita ada macam ni. 2x plus 5x kuasa 2. Kita nak cari pembezaan dia. Dia akan dapat apa? It is, okay, ni kuasa 1 Okay, it is 2 plus 10 x. Okay, any question for this? Kita bezakan satu per satu. Okay. Then we have product rule. Product rule ni selalunya it is involved like this. Contohnya ln x, and kat depan ni ialah 2x ln x, which is it involve two things. Dua benda. Okay, then we solve it by using product rule. Product rule ialah rumus dia macam ni. Kita ambil contohnya ini ialah kamu punya G, yang ni kamu punya F, dan kita bezakan macam ni. Ambil G, bezakan F, plus ambil F, bezakan G. Or previously you learn about U, B prime plus B, U prime, macam tu. Any question? So far so good? Okay, then we go for the example of this sum rule. Okay, this is the sum rule, example of sum rule, which is we differentiate one by one. 5x, we differentiate it, we get 5. Okay, bagi yang tak tahu, kalau 5x ni ialah 5x kuasa 1. Bila dia kuasa 1, 5 tetap dekat luar, 1 ni ialah C kita kan. Jadi 1 letak kat depan, x. Ni 1 ni, 1 tolak, which is 1. Dia akan dapat apa? Dia akan dapat 5, 1, x kuasa kosong. Bila apa-apa benda yang kuasa kosong, it become 1. And 5 times 1, so that's why we get only 5 at the end. Then Ya, ini clear lah ya, macam contoh tadi tu, constant coefficient tu. Okay, we have this, then we get 4x. Okay, any question for this? Don't have question, we move to the product rule. Okay, actually this kind of question, we can solve it by using, kita darabkanlah dulu, which is we had here 10 X kuasa 2. Then 10X kuasa 2 kita bezakan dia, kita dapat apa? Kat sini. Kita bezakan dy over dx, we get what? 10?
20x.
20x. Finally we get 20x. But this kind of question dia nak nampak the product rule tu. Okay, sebab kita belum masuk rule of ln, rule of exponent. Okay, sebab tu dia guna equation biasa je. Okay, for example, this is of your f and this is your g. Dia tak kisah tukar terbalik ke apa ke. Okay, then here we know that we put g and we differentiate f and we take f, we differentiate g in product rule. Then we solve it, we get this final answer. Actually, if you multiply it first, then you get also the same answer for this. Then we go next. This is the quotient rule. Okay, this is the quotient rule. It involves when we have pembahagian macam ni. When we have pembahagian. Jadi kat sini, yang ni dia quite sensitive. Bukan macam product rule. Dia kalau G dekat bawah, sentiasa G kat bawah and we must put G first, then we differentiate F. F yang dekat atas and it is minus. Because of it is minus, it is not plus, we have to more careful on this. Which is we have to put G first, we differentiate F, and we put F, we differentiate G. We minus it. Then the denominator Gx become Gx power 2. Okay, this is the quotient rule. Okay, and this is the equation of the formula for chain rule. Chain rule ni macam mana? Bila kita ada something yang dalam ni. Okay, kita tengok contoh Okay, dan bila kita ada something dalam tu, nampak tak? Kita bezakan yang besar F, kita bezakan F, dan yang dalam ni G, kita bezakan dia kemudian letak di luar. That's the chain rule punya formula. Okay, look at the example. Okay, here. Okay, this is the quotient rule. Okay, look at this. Which is, this is our G. G nampak tak letak dekat bawah? Kuasa 2. Then we know that our G here, we tulis je balik yang ni. Bezakan our fx. Bezakan our fx, we get 2x. Then minus. Here we put our G. We put our F here. This is our F. Then we differentiate yang bawah ni. Differentiate yang bawah, kita dapat yang ni. Okay, tengok. Ingat balik rumus kalau kita rasanya kalau dulu kamu belajar U dengan V U dengan V. And kat sini akan dapat V kuasa 2. Ni ialah V differentiate U minus U differentiate V. Which is here V. Tulis je V tu. Ni lah. Dapat ni lah nanti. Okay. Then here. Okay, untuk equation ni dia tak selesaikan. Saya rasa bila kita selesaikan ni, it become more complicated. So, leave it by this only. Then, we go for example 7. This is the chain rule. Okay, for this kind of question, jadi dia mudah sikit. Kenapa? Saya kata sebab kat sini dia dah nyatakan Y kita dalam bentuk U. And this is our U. Then in this chain rule dy over dx, you have to differentiate. Ni dy Dalam dia U kan, dia jadi dy over du. So, bezakan yang atas ni, bezakan yang ni. So, kita dapat 3U kuasa 2 tolak 6U. And this is U X kuasa 2 tambah 2. Okey, kat sini kita akan dapat 2X. Ni ialah du over dx. Bezakan dia terhadap X. And in this chain rule, kita tahu kita kena guna dy over d. Okay, this is the correction dy over du sebab ni times du over dx. Okay, so yang ni kita just tulis balik yang ni. Letak dia di sini. Yang ni letak dia di sini. Kenapa? Sebab ni ialah daripada sini dan ini daripada sini. Okay, so far so good. Okay, boleh. Yang ni. Then we transfer it again. We know that our u last kali tak boleh dalam sebutan u. Jawapan kita kalau dalam x, x sahaja. Which is here we know that our u is x square plus 2. We replace in the u punya tempat. Kita replace dia kat sini. Kat sini pun sama. Kita replace dengan equation yang ini. Then we get the final answer. Okay, this is the example of chain rule. Actually, this is not the good example of chain rule. Sebenarnya dia tak bagi tahu pun, tak boleh, dia tak bagi tahu pun you yang mana. You have to decide it. But after this, we look at more example about this chain rule. Because we frequently use this chain rule. Okay, any question? Okay. Then we have this. This is the power rule. Okay. Yang ni ialah power rule. Kenapa? Sebab kita ada CFX. Contohnya macam ni. Kita ada 2X kuasa 2 campur 1 kuasa 3. Okay, this is our Y. Okay, nampak tak kat sini? Di dalam dia ada Fx, kat atas dia ada kuasa. And this is our Fx. Bila kita nak cari dy over dx, bila ikut power rule ni, okay, dia boleh dua keadaan. Kita boleh guna chain rule or we can use power rule untuk this kind of soalan. Okay, so untuk soalan ni, kalau ikut rumus sini, maksudnya dia akan jadi 3 dalam kurungan 2x kuasa 2 tambah 1. Yang ni akan tolak 1. So 3 tolak 1 ialah 2 darab dengan yang dalam ni. Dalam ni kita kena bezakan. Okay, so 2x kuasa 2 tambah 1 bezakan dia dapat berapa? Okay, so kita boleh selesaikan equation ni. Dia dapat 12x dan it is 2x square plus 1 power of 2. Okay, this is the final answer. Okay, this is what the power rule all about. And this is the log, natural log rule. And it always ln x akan sentiasa jadi 1 per x. Okay. Then we look at the example. Okay, this is the power rule. Power rule just now. Sebenarnya power rule ni bila kita guna power rule tadi, dia akan jadi apa? 3 letak dekat depan. Dalam ni ialah x campur 4. Atas tu ialah kuasa 2 darab dengan 1. So the final answer 3 darab 1 ialah 3 lah. So this is the final answer. Okay, kalau guna power rule. Nampak tak? Akhirnya sama. But this contoh, dia guna chain rule. Kenapa? Okay, so sekarang dekat sini, it depend. Terpulang dekat kamu. Bila kita guna chain rule untuk contoh ni, kita ada macam ni. Ni semua dijadikan semua ni sebagai U kuasa 3. And all this thing we put it as U kan, U kuasa 3 dan dalam ni semua X campur 4 sebagai U. And we get du over dx is equal to 1 and dy over du is equal to Bezakan ni 3U kuasa 2. And by using the chain rule punya formula, we have to darabkan 2 ni. Okay, bila kita darabkan, kita dapat 3U kuasa 2. And our U place, we have to replace it back with X campur 4 just now. So kita letak baliklah kat tempat U ni. So kita dapat jawapan ni. So kita ada dua jawapan. Dua cara, whether you want to use power rule straight away or you use chain rule to solve this kind of question. Okay. Clear But mostly I think in this slide they frequently use chain rule. Okay, this is the lawn. Okay, here we know that we have 5 constant dekat depan. So 5 constant we can put it outside. Then ln x is equal to 1 over x when you use the rule. Then it is equal to 5 over x. Any question? No, Okay, this is natural exponential rule. Okay, in this, kejap kat sini, natural exponential rule. Kat sini, kita tahu eksponen x sentiasa akan dapat eksponen x juga. Dia tak berubah bila kita differentiatekan. And for exponential rule, okay, this is natural exponential rule, exponen x. But if we have exponential like this, bila kita ada 5x campur 1 kuasa x. Okay, nampak tak? X dekat atas. We have to use this rule. Okay, dekat sini AX. Di mana jawapan akhirnya akan jadi AX ln A. Okay. Contoh yang ni dia kena guna chain rule ni. Okay, bila kita guna contoh yang senang, yang ni boleh jadi kerja rumah ni. Cuba selesaikan untuk yang ni selepas kita belajar semua. Okay, so sekarang dekat sini, AX ln A yang ni. Okay, bila kita ada 5 kuasa X, this is our Y. Nampak tak? A kita ialah 5, X kita ialah kuasa tu. Then we want to find dy over dx. So it is what? It is 5 or our X ln A is 5, right? So ln 5. Okay, this is final answer dia. Or if you have chain rule, A power of X, you have to use the chain rule. Nanti kita tengok contoh. Yang ni pun boleh tengok contoh ni. Or we have like this. 5 kuasa, cuba jawab ni. Yang atas ni dan dekat sini saya bagi ni lah. Kalau ada soalan boleh tanya nanti dalam kelas. X kuasa 2 campur 2. Macam ni. So how can we solve it? Kita ada kuasa kat atas tu. And it is exponential rule by using this type of formula. Okay, kita ada dua soalan. Yang ni, challenge yourself. Please solve these two things. Okay. Then we go for the next slide. Okay, this is the example of natural exponential rule. Okay, nampak tak kat sini? Dia bukan sahaja exponential x sahaja, but in our x here, dia ada satu equation ni, 3x campur 4. Okay, yang ni memang nak tak nak, we have to use chain rule. That's why we have to dapat betul-betul what is chain rule. Okay, so sekarang kita tahu eksponen x akan dapat eksponen x juga. So kita gantikan semua ni kepada u. And 3x campur 4 tu kita ganti sebagai u. Dan equation kita akan jadi y sama juga eksponen dalam kotak ni akan jadi u kesemuanya. Okay, so it is like this. Then we have to solve it by using chain rule. Dy over du, bezakan yang ni, kita akan dapat dy over du, yang ni lah dy over du, bezakan eksponen u dapat eksponen u juga. And this equation we get 3, right? 3x plus 4, we get 3 as a differentiation. Then the final answer, we multiply it to these two, we get 3 exponent u. Then the final answer, we replace back our u here, we get 3x plus 4. Okay. Kenapa kita guna chain rule? Sebab kita tahu bahawa eksponen x dapat eksponen x sahaja. So kat sini kita jadikan dia more simplest thing, which is eksponen u dapat eksponen u juga. But we produce this u ni kat sini. So that's why we use chain rule. Okay. Okay ke? Then this is example 11. We have to solve it by using exponential rule. Okay, nampak tak kat sini? 5x, which is our A ialah x. Ini ialah contoh saya tadi dah. 5x ln 5. Tengok dekat rule tadi. And this is the another example dekat sini kat sini. Nampak tak? Kuasa patutnya kat sini ialah x, but it is 3x plus 5. So we replace all in this circle into u. Then this is replace it. Then we get our y it equal to 4 power of u kat situ. Then we solve it guna apa? Ni 4u, nampak tak kat sini? 4u, lepas tu ln 4 du over dx. Okay. Lepas tu kita selesaikan dia, kita dapat yang ni lah. 4u, u selesai, masukkan baju balik, kita dapat ni ln 4, bezakan yang ni du over dx. So kita dapat 3. Then we simplify this equation, we get this. Okay, faham? Nak break 5 minit dah berasap Kita ada Tan Kintong minta kita break. Okay, kita break kejap Kita break sampai 11.55. Okay, so this is the exponential rule just now. Okay, then we go for the higher order differentiation. This is the higher order differentiation, and this is first derivative, second derivative. What is it actually? Okay, we find the derivative for the first time, then with this result, we find the second derivative. And with this kind of result, we can find third derivative. Dia macam berkait until you get yn and fn derivative. Okay, sometimes there is question why we have to find until yn fn. Sebenarnya bila kita dalam situasi real life situation, contohnya saya pun tak tahu dekat mana kita guna. Sebenarnya saya suka kalau kelas matematik kita bila kita buat when we learn, we know that this type of equation you can use it later, which is kenapa kita kena cari yn until fn. We want to find the changes and changes again. For example, we want to find halaju. After we find halaju, we want to find pecutan, right? Okay, sampai pecutan kita cari. But in some situation, for example, previously my lecturer, which is Prof. Hotlai, dia ajar saya, dia guna this kind of pembezaan yang higher order, dia guna pengamiran yang higher order. Kenapa? Sebab dia nak cari pollution, which is dia nak cari changes yang macam mana this kind of pollution ni akan berhenti. Dia punya kajian masa tu ialah pada sungai di Pulau Pinang. Okey, bila dia buat kajian tu dia boleh keluarkan one equation, apa dia boleh dia guna equation yang memang higher order, dia boleh dapat one conclusion. Apa ya dia punya conclusion tau, which is dia boleh dia bagi tahu in 10 years time, which is dia punya dapatan tu, dia kata bila kita ada dalam jangka masa 10 tahun, bila sungai Pulau Pinang tu dia punya tahap pencemaran, dia punya yang masuk dekat dalam sungai tu kekal sama dengan taburan hujan yang kita ada apa semua, dia kata sungai tu akan bersih tanpa ada pencemaran baru yang masuk, dia kata macam tu. That kind of study yang memang guna higher order differentiation and integration. You have to know it. Then you appreciate what you had learned today. Okay. Sebenarnya bila kita buat image processing, bila kita buat pattern recognition later pun sebenarnya kita guna juga untuk calculus ni. Okay. Saya sebelum ni saya buat apa? Saya nak cerita sebab kamu BITM kan. Okay, it's okay. But I want to introduce to you what I had research in my PhD, which is dalam image mata. Saya buat image processing. It's quite dekat lah dengan kamu BITM kan image. I want to know where is your eyes. Kalau eyes tu kan dekat mana yang kita punya iris. Kat situ. Nak cari region of interest ni sebenarnya kita guna this kind of differentiation ni. Sebab kita nak tahu that kind of pattern, ada iris dalam tu. Macam tu lah. So kat model tu, how to model it. Okay. So yang tu lah kat situ. And this is the example of first, second and third different derivative. Okay, so sekarang dekat sini kita tahu tadi kan kita kena cari first, second. Okay, yang ni saya kena buat lah, ni tak ada jawapan Okay. Yang berlari ni Adli, kenapa? Nak cepat sikit ke apa? Saya rasa macam saya kena laju je bila saya nampak benda yang berlari tu. Okay, so sekarang dekat situ dah bagi pura-pura pula Sekejap. Okay, so sekarang dekat sini kita ada cari dia punya first differentiation. Macam tu lah. Yang ni, cari dia punya first differentiation, kita dapat 5 X kuasa 4 campur 12 X kuasa 3 tolak 6 X kuasa 2 campur 20 X. Saya salah bagi tahu saya main buatnya ni. Okay, ni ialah 5. Okay, this is first differentiation. If you want to find the second derivative, which is we have to differentiate the first one. We get 20x power of 3 plus 36x power of 2 plus minus 12x plus 20. Okay, then we can find the third derivative. It is 60 36 power of 2 berapa? Nanti carilah. Okay, maksudnya untuk cari second derivative, we have to differentiate first derivative, third derivative, we have to differentiate second derivative. So next is implicit differentiation. Okay, what is implicit differentiation? You can see from this kind of equation, it involve unknown tu ada dua. Ada y, ada x in one equation. Okay, equation tu is not y is equal to x saja, it's not that, but it involve variety which is x and y. Okay. Okay, we look at the example. Okay, for example this. Okay, so sekarang kita tadi implicit, right? So kat sini kita kena bezakan untuk 3y power of 3, we want to find dy over dx. Okay, so kita bezakan macam biasa. 3y kuasa 2. Ini biasa kan? But every time because of y ni kat atas, kita nak cari dy over dx kat situ. So kat situ, every time we differentiate y, we have to put dy over dx. And if we differentiate again y power of 2, it get 2y, but because of y, we differentiate it, we have to put dy over dx. And it same goes to negative 5y. We differentiate it, we get 5 only, minus 5. And because it involves y, we put dy over dx again. And here, we differentiate negative x power of 2, it become negative x. Okay, only. Okay. Can you spot the difference there? X sahaja, but when it comes to y, you have to put dy over dx beside. Okay, then we solve it. Yang dy over dx, we letakkan dia sekumpulan di sini, dan 2x we move to the right because of we want to factorize dy over dx. Then all these things we put it as a denominator to the right. Then we get dy over dx is equal to this as a final answer. Are you clear? Okay. Okay. Then, kenapa kita buat implicit differentiation? Because of this. Kita nak x kuasa 2 campur y kuasa 2 ni ialah persamaan untuk bulatan. Okay. And in this kind of bulatan, kita boleh cari dia punya slope. Kita boleh cari bulatan ni kecerunan dia berapa slope dia. Okay, untuk soalan ni, dia nak cari slope. Okay, untuk soalan ni, to get the slope, we know that just now slope is first derivative. So, kita kena cari dia punya first derivative. Okay. So, first derivative dia, kita bezakan x kuasa 2, kita dapat 2x. Kita bezakan y kuasa 2, kita dapat 2y. But remember again, every time you differentiate y, put beside it dy over dx, and 1 is constant, we get 0. Then, we simplify, we solve it, we tinggalkan dy over dx as a perkara rumus, and everything we put it as in the right, we get the slope is negative x over y. Okay. Any question? Ni satu soalan. But here, if we get this kind of equation, okay, nampak tak? Soalan ni, dia tak adalah macam dulu-dulu kita belajar masa matrik ke, masa STPM ke, kamu kena produce formula untuk ellipse dengan bulatan kan? Ada ke belajar? Saya ada dulu belajar. Tapi saya dulu tahun berapa lah, lama. Kamu ada belajar? Ada. But here, you don't have to worry about it if you have soalan yang macam ellipse ke, bulatan ke, but they gave you the formula already. No need to create it. But here, just find the slope of this ellipse at point this. Okay. By using this formula, we have to find the first derivative because the question asks about slope. Okay. Find the first derivative, x squared is 2x, 4y squared is 8y, and y dy over dx here, and 4 is 0. Then we solve it like previously, which is we jadikan dy over dx as a perkara rumus, then we get this is the final answer. And by using this final answer, we put the coordinate that we want to find the slope. The coordinate is here. If you draw the graph, okay, then just put x as a set 2, replace x as a set 2, and our y here is as negative 1 over set 2. Then get this is the final answer. Okay, any question? Okay. This is the application of derivative. Okay, nampak tak kat sini? Dia punya application dekat dalam straight line motion, increasing, decreasing function, dalam this stationary function, stationary point. Stationary point ni macam dulu kita belajar extremum point. Extremum point tu ialah maximum, minimum. Or another one is what? Titik lengkuk balas tu in English apa Apa? And second order derivative and optimization problem. This is the application of this apa? Derivative. Okay, ni soalan ni ialah bila kita ada objek yang bergerak in a straight line, so that after t second the displacement of x meter from the point O is given by this. And here first we want to find the velocity, initial displacement velocity and acceleration. Okay, because of it is initial, maksudnya dia tak bergerak lagi, dia tak ada masa lagi. So sekarang kita carilah untuk A tu ialah dia cari velocity ialah pembezaan peringkat pertama and acceleration ialah pembezaan yang ni pada peringkat kedua. Bezakan kali kedua. And pada masa kosong because of initial. And we get it as 9 and 6. Gantikan T sebagai kosong. Okey, yang ni lah tadi. Kalau dia ialah velocity, dia ialah pada pembezaan peringkat pertama. And apabila dia ialah acceleration, dia ialah pembezaan peringkat kedua. Okey. And this is the formula untuk dia increasing or decreasing function. Maksudnya sekarang, bila dia dy over dx dia greater than 0, it is increasing. And when it is less than 0, the first derivative, it is decreasing. For example, here is the function fx. They gave you the equation fx. Is it increase or decrease at point x is equal to 3? So now you have to find the first derivative from this equation. Okay, find the first derivative from this equation. Ni kan equation dia. Okay, find the first derivative. Okay, after that you put x is equal to 3 inside x. Then you get this. Then you know that it is less than 0. So we can conclude that this kind of function at point 3, it is decreasing. Okay. And this is the example. Kita nak tahu range dia. Dekat range mana dia decrease? Yang tadi kita tahu dia satu titik saja. But kita nak tahu daripada titik berapa ke titik berapa dia decrease. Okay, so now we know it by using this. Macam ni. Okay, so sekarang kita dah buat dia peringkat pertama kan? Okay, lepas tu kita tahu it will decrease when it is less than 0. Then you have to find the value of x when it is less than 0. When it is less than 0, the value of x, kita boleh sketch je kat sini. Macam ni. Okay, bila kita tahu dia less than 0, dia di antara 0 dan 4 kan? Ini ialah 0, ni ialah 4. Bila kita lukis dia di bawah garis kosong tu, merah ni, maksudnya kita tahu bahawa dia ialah decrease when it is from 0 until 4. It is not include 0 and not include 4 because that's why when we plot it, we put it as a whole. Maksudnya kita bukan satu titik yang fill. Macam tu. Okay. Then this is maximum and minimum point. Okay, how to find minimum and how to find maximum. Okay, yang ni dia tak nampak. Kejap Dia sebenarnya macam ni. Nanti saya bagi saya punya apa PowerPoint. Kat situ dia ada graph. Dia ada gambar sebenarnya. Okey, tak apa. So sekarang kat sini kita nak cari stationary point. In order to get the stationary point, maximum ke minimum ke atau it is turning point. Okay, so we have to find dy over dx is equal to 0 first. Kita tahu bila stationary point ni ialah pada dy over dx sama juga dengan kosong. Kenapa? Okay, sekarang maksimum ke minimum. Contoh kat sini. Ini ialah maksimum kan. Kenapa dia kata dy over dx sama juga dengan kosong? Kerana slope dia dekat sini. Slope dia Ni nilai kecerunan ni ialah kosong. Kenapa dia kosong? Cuba cari dia punya contoh kat sini ialah titik 3. Y dia. And ini ialah 1 dan dekat sini ialah 2. Okey, kita boleh cari dia punya ni titik yang pertama. Yang ni kan kecerunan untuk garis ni ialah kosong. Kenapa 3 tolak 3 bahagi dengan untuk satu titik dekat sini, satu titik dekat sini. Okey, dan bahagi dengan 2 tolak 1. It will become 0/1. Dia memang sentiasa kosong. Dia punya slope tu is horizontal. Okey, kalau dia minimum macam ni, minimum. Okay, it also horizontal here. So means that the slope is 0. So kita tahu bila dy over dx dia ialah kosong, ada satu titik maksimum or titik minimum or turning point. Turning point pula macam mana kan? Kat sini kan kalau macam turning point dia macam ni. Bila dia turning point akan ada satu titik dia rata kat sini. Anggapkan tu saya ni garis yang lurus lah ya. Okey, maksudnya kat sini ialah slope dia kosong. Okey, oleh sebab itu kita tahu bahawa ada tiga keadaan. Sama ada dia maksimum, minimum ataupun it is turning point. Okay then. Here. First, in order to get the stationary point, we have to find its first derivative. Okay. At dy dx is equal to 0. So sekarang kita cari first derivative untuk ni, kita dapat ni. And samakan dia dengan kosong. So kita nak tahu titik apa yang dia ada stationary point. So kita tahu dia dah ada stationary point pada titik 2 dan negatif 2 by solving this equation. Ada dua titik kita kena consider now. And your task now is to determine dua ni positif, maksimum ke minimum ke turning point. Yang ini pun sama. Maksimum ke minimum ke turning point. Okay, then next step is, okay. Sebelum kamu tahu dia maksimum ke minimum, kita nak tahu the coordinate itself. Put the value of x is equal to 2 into the original equation, you get the value of y. So kita tahu titik yang pertama tu, koordinat dia ialah 2, negatif 9. And titik yang kedua pada negatif 2, put it back to the original equation. Original equation, remember here? Yang ni? Okay, then you get 23. So the two coordinate that had the stationary point is 2, negative 9 and negative 2, 23. Then you know how to determine that. Okay, so sekarang macam mana kita nak determine? Okay, kita tahu bahawa dia punya first derivative 3x kuasa 2 tolak 12 tadi. Okay, kita boleh buat table. This is one way. We can draw a table. So we know that the stationary point is at point 2. Okay, here 2. So before 2, ambil satu titik sebelum 2. So this person take 1/9 and another titik selepas 2 ialah 2.1. Okay, so sekarang kita masukkan 1.9 dalam equation derivative ni. Okay, kita dapat negatif. So kita tahu bila dia negatif, it is decrease. And bila dia positif, it is increase. But when it is 0, it is flat. Kalau yang ni, kita lakarkan, dia akan dapat something yang macam ni lah kan. It is minimum. This is one way how to decide this titik ni. Minimum ke maksimum. Okay, kita ingat tadi kita ada lagi satu titik. So kita kena buat cara yang sama. Yang ni. So lagi satu titik ni, ialah ni. So kita kena pilih satu titik sebelum dia iaitu negatif 2.1 dan selepas dia negatif 1.9. Okey, so sekarang dekat sini kita masukkan titik ni ke dalam tempat X. So kita dapat positif. We know that it will increase. And this kind of equation when it is 0, it is flat. And when it is negative, it will be decreased. So now it is maximum because of this. Kita boleh lukis dia macam ni kan. So it is maximum turning point. This is one way how to determine it. And there is another way, which is we use the second order derivative to know whether it is maximum ke minimum ke. Okay, tapi saya rasa kalau untuk turning point, kita memang kena guna yang ni. kita akan dapat satu naik, lepas tu dia macam ni, dan lagi satu pun increase, which is we know that our turning point is like this. Macam tu. Okay. Dan ini kalau kita guna second order derivative. Okay, kalau second order derivative, apa kaitannya dengan nak tahu apa maksimum ke minimum ke guna second order derivative ni? Okay, kita tengok Okay. Ni optimization. Sekejap. Macam ni. Contoh yang tadi apa? Second derivative tu. Okay, sekarang macam ni. Using second derivative yang ni, okay, kita tahu bahawa dia maksimum bila nilai second derivative dia less than 0. And dia ialah minimum bila second derivative dia greater than 0. Dia terbalik Maksudnya dia terbalik dengan increase decrease tadi tu. And bila dia sama dengan kosong, dia boleh jadi maximum, minimum or point of inflection. Yang ni memang kamu kena guna table bila this kind of case involved. Okay, then how to use it? Kita tengok contoh yang ni. Okay, ini kan contohnya yang ni. Okay, so sekarang kita nak tahu. Soalan dia cari dy over dx and d kuasa 2y per dx kuasa 2. Okay, so sekarang dekat situ dia suruh cari. So kita dah carilah, ni soalan A. And find the coordinate of any stationary point on the curve and determine their nature and sketch the curve. Okay, now we answer the question B and we want to know the stationary point. Back to the concept which is stationary point, it will involve when the first derivative is equal to 0. So we get this when it is equal to 0, the x value ialah -1 dan 5. So kita tahu bahawa kita ada dua titik. Dan kita untuk titik yang pertama, x sama juga -1, nilai y dia ialah 8. So koordinat dia ialah pada titik -1 dan 8. Apa kaitannya dengan d kuasa 2y per dx kuasa 2? Masukkan nilai -1 ni ke dalam equation d kuasa 2y per dx kuasa 2, we get it is negative number. When it is negative number, so we can conclude it is maximum. Guna yang tadi teori tadi. And the second one is x is equal to 5 here. The value of y is -100. So kita dapat dia punya koordinat. Okay, so sekarang lepas kita dapat dia punya koordinat ni, okay, kita cari nilai 5 ni, masukkan ke dalam second derivative ni. So we get positive 18. When it is positive 18, d kuasa 2y per dx kuasa 2 lebih besar daripada kosong. So it is minimum. So when we sketch the graph, we can show that this point it is maximum and this point it is minimum. So finish with this, but we have another problem just now. It is here optimization problem. So sekarang kat sini farmer has 60 meter fencing which to construct a rectangular enclosure again an existing wall. Find the dimension of the largest possible enclosure. Jadi kita nak tahu the largestnya. Okay, so the idea here is kita tahu dengan kita cari dia punya perimeter, right? Kita nak tahu perimeter. So perimeter dia 2 lebar length plus 2 width plus length, which is inilah, kita ada 2 W and 1 L. So sekarang daripada sini kita tahu bahawa kita boleh write this kind of equation in dalam bentuk L. Okay, so sekarang dekat situ sebab kita nampak kita ada dua sebutan tau kat sini. So kenapa kita buat ni ialah kita tahu area-nya ialah W kali dengan L. So why we have to choose this? Because of kita nak cari area dia, enclosure is ni W. So our L here it is in W expression. So dia tak involve ada sebutan L, ada sebutan W kat dalam tu. So nampak tak? Ini ialah area yang kita dapat dalam sebutan W sahaja. So lepas tu kita kena selesaikan masalah ni dengan mencari maksimum area, iaitu kita tahu kalau nak cari maksimum kita kena cari dia punya first derivative, right? So kita differentiate yang ni. Differentiate kita dapat 60 tolak 4W. Then here kita cari pada titik sama juga dengan kosong sebab kat situ dia punya stationary point. So bila dia sama dengan kosong, our W is equal to 15. So we know that the maximum area is therefore achieved when the width of the enclosure is 15 meter. So the dimension of enclosure in this case are 15 meter by 30 meter and the area is 450 meter square. Okay, because of we know that our width is 15. Back to the equation here. Bila width to 15, masukkanlah nilai L tu kat sini. Gantikan. So kita dapat, nanti kita dapat L tu ialah 30. So bolehlah cari dia punya area di 450. Okay, yang tu kalau boleh faham, insyaAllah faham kot. Okay, so we finish with our lecture today. Okay, sorry yang untuk G2 tu saya rasa if you need a class before that, please let me know, then I will book for you. Bagi tahu saya petang ni tau, sebelum office hour tutup. Okay.
Okay, doktor.
Okay.
So masih face to face ah.
Saya rasa sebab timbalan dekan memang dah letak kat situ face to face. Kalau saya tak buat face to face macam satu kesalahan lah juga. Dan lagi satu, we appreciate for those yang memang dah datang campus macam tu lah dia punya concern. But I still put a kelonggaran, which is if you have kalau demam, sesama, pening, batuk, it's okay. Just write me later. Okay.
Okay.
And then I put the archive then inside the ULEN. Okay.
So later if our group come out with a decision, we tell you in the group lah.
Okay.
For the tempahan.
Untuk tempahan, betul. Please
Yeah.
let me know. Okay.
Okay.
Okay. I try to, because of you involve the group you only, which is group 2 only, I try to get the lab because you are in a small group, right? So
Yes.
it's more comfortable in a lab compared to the lecture hall. Okay, I try to get the lab.
Yes. Lab is better. The lecture hall is a little bit too large.
Okay. Okay.
Okay, thank you.
So we finish with our lecture. Thank you. Assalamualaikum.
Thank you, doctor.
Thank you.